Do you want to learn embedded Linux and you are totally confused on where to get started? Or you want to switch to your career to embedded Linux and you have tried several times to learn the same, but somehow you feel that embedded Linux is an ocean and you tend to get lost in the sea. So, if your answer is yes to any of these questions, then you are at the right place because here I am going to provide you the ultimate roadmap to embedded Linux. Hi, I'm Pradeep Devani. I'm a trainer and consultant for over 17 years. I have been into embedded systems and I have delivered several corporate trainings. To know more about me and the courses which I offer, please refer the description. Now, let's get started. So here is the ultimate roadmap to embedded Linux development. Before we get there, it is very important to understand how does the embedded Linux system looks end to end. So let's first look into the big picture. Here what you will notice is overall your embedded Linux system or a Linux system is being divided into three spaces. The first one of them is of course the hardware space. Now what is hardware space? The hardware space is one where you have all the hardware being placed. That means your hard disk, your keyboard, your mouse, your network card and all of those things are being placed at this particular hardware space. Now, as you know, in order to operate these particular hardwares, you basically need the code. You need basically a low-level code. Typically, we call it as a firmware or driver or whatever you would like to name it. And that low-level code is placed in something called the kernel space. So if you are not aware of what the kernel space is, for time being, you can say it is like an operating system space. It is where the operating system runs. So operating system has the full privilege to the hardware and it can basically control the hardware. You can control the hardware from here. In the Linux terminologies, we also call this space as a driver. We call this particular low level code is as a driver. Now, of course, you can have the code which is specific to the hardware, but you also need some code which is generic, which is independent of the hardware. For instance, your scheduler and all those kind of things. So that is basically being placed in the generic code. Now, this generic code plus the low level code together is what we call it as the kernel space, or I can say the overall kernel as such. Now, what happens is there is something which is very much important from the user perspective where your user applications run. So, for example, your PowerPoint, the shell, the Word document, or your uh, browser, for instance, all of these basically run into the user space, and this user space is typically a unprivileged space. So what do I mean by unprivileged spaces? Let's say basically you want to write some file into the hard disk, so you cannot actually access this hardware space directly from this particular user space. What you need to do is you basically need to take the help of the kernel. So this is where the kernel provides some service points which we typically call it as a system calls. So user space can access this particular kernel space or the hardware space through the system calls, or we can say or to keep it simple we can say basically it's like service points which are being provided by the kernel through which the user space can request the services from the kernel space. Now, let's say you want to write the file to the disk, you will place the request to the kernel space, and this kernel space is basically going to perform the action on your behalf. So that's how the overall system looks like. So before even jumping onto the embedded Linux development roadmap, we should be very clear with this bigger picture. Now, let's move on. Now, let's move on the basis of that particular diagram which we have seen, whatever that big picture we have seen, there are various learning paths or learning tracks. So let's look into this learning tracks one by one. So the very first learning track which you have is the Linux application developer. We will be going into the details of these parts. So first is the Linux application developer, another one is the Linux driver developer, then you basically have the BSP developer, and then you have the embedded Linux system integrator. So let's look into the learning parts one by one. Now, what is this Linux application development? Application development, as the name itself suggests, is something where you develop the applications. Let's say I'm developing the applications like Firefox. Let's say I'm developing the application like a word processor. So these all are basically the applications. So while developing the applications, you need to develop some skills, like you should be knowing the various programming constructs to write the application. So one of them is basically the process management. Processes are basically, I can say, the building blocks of a Linux system. That means anything which is running, application it is running, it will be running as a process. Next, in a process management, you need to know how to create the process, block how to block on the particular process, the zombie and the orphan process. So this is what we call it as a Linux user space internal. So that's a part of it. Another thing, of course, you would like to know is something about the lightweight processes. Now, what are lightweight processes? We typically call them as a threads. They are the basic units of execution. So here also how you need to look into the thread creation, joining the thread, thread cancellation, and all that stuff. Further, you also need something like a inter-process communication. Now, what is this inter-process communication? Let's say you have a two processes, two programs in a system, and you basically want to make them communicate. Of course, like when you have a system, you can't expect all the processes to be independent of each other. So you need to basically establish the communication between them, and that is basically being done through the various communication mechanisms like pipes, FIFOs, shared memory, and there are various other stuffs as well. And the next thing which you of course have, like when you have multiple entities operating simultaneously, you need something like a synchronization mechanism to solve the concurrency issues. So you need to basically learn about something like a mutex, semaphore, conditional variables, and something like that. And the final stuff which you will be basically having in the application development, which is very important, is which helps you communicate across the systems, and that's what we call it as a network management. Typically in the Linux, the network management happens with the help of socket programming. All right, so this is the learning track for the embedded Linux development. Now, before even you move on to the driver related stuff or embedded Linux related stuff, you need to be very clear with this application fundamentals. Next path which we have is of course the Linux driver, the hot favorite from for most of you guys. Now, how do you start with a Linux driver developer? So first of all, you basically need to look into the driver basics, what the driver is, why do you actually need the driver, and all those kind of stuff. Then you need to need to basically learn about the character driver. Now, character driver is one of the simplest uh, driver which you have in place. So very first thing is you should be thorough with the character drivers. Further, you need to know how do I interact with the hardware. So let's say taking any small hardware like any sensor or LEDs or switches, how do I basically control that? How do I receive the input from that? That's what you need to know the next. Now, once you are done with that, you need to basically now move on to the kernel internals as well. Now, what is kernel internals? Kernel internals means the way you basically write a C program, right? Now, you know C program can't with the help of C program, you can't develop any sophisticated application. So that's where you need to learn the application development, where you need to know the various data structure and the constructs used to write the application. So on the similar lines in the kernel also, you need to know about the synchronization mechanisms, the kernel threads, and all that stuff which will help you write a complete driver. So that's where you need the kernel synchronization, then the timing management, interrupt management, of course, very important when you are an embedded developer. Further, you need to move on to the advanced drivers like a platform drivers, device tree related stuff, various frameworks like I2C, SPI, and all those kind of stuff. And further down, you have something like advanced drivers, the network drivers, block drivers, file system drivers. But I would say like even if you are able to cover till this point device free binary point of time, and let's say the drivers like a I2C and SPI, you are good to go with a driver development, because network block audio drivers and all are basically niche which very few companies might be needing. As long as you are comfortable with this particular stuff, you need not worry as such. All right, so this is the learning track for Linux kernel and the driver development. Now, coming to the another important learning track, which we call it as a porting or BSP development, which is in a great demand as such, similar to the Linux driver development. Here also you need to basically get started with the various stuff. You need to learn the various stuff. So what does it actually involve? So first of all, let's understand what the porting is. So if you ask me, porting means adapting. That means, as you understand, in embedded systems, Linux is a platform which has been ported, which works on the variety of platforms. So this platform, basically this Linux needs to be ported for that platform. It needs to be adapted to that platform. So that's what we call it as a porting. So let's say you have a board one and your Linux is working on the board one, and let's say now your organization has developed one product, and that particular product is based out of this board. But what you need to do is this whole Linux thing which is working, the bootloader, the drivers, and your whole kernel which is working on this particular board one, you need to make it work on board two. So that's what we typically call it as a porting. Now of course it involves little bit of BSP development as well. Now what happens is typically the driver development and the BSP development has a very thin line in between. So once you are a driver development, you can also do the BSP development as well. Okay, so now as I told, it means the adapting for the particular platform, adapting for the CPU, adapting for the SOC, adapting for the board, and components which needs to be ported, the bootloader, the kernel, the drivers, the root file system. Now, what is the root file system? In a nutshell, you can say like whatever you see from the user's perspective under the slash, that's your root file system. All right, so hope it provides you a bigger picture on what the porting and the BSP development is. With that note, let's move on to the next stuff. And that next stuff, which we have, the next learning path you have is basically embedded Linux build or integration engineer. Now, here what you do is you typically deal with configuring the kernel for the particular platform. Part of it will also fall into the BSP development or porting related stuff, but here you typically deal with something like a build systems, like I can say like dealing with a build systems like a Yocto and the build root. So that's what this build and integration involves. And in many things, many a times what will happen is that the embedded Linux developer, I would say like the guy who is a BSP developer and all, he might be well versed with a build root and Yocto, because these are the tools which allow you to integrate the overall system. So in that case, this learning path can be merged with a embedded Linux porting or BSP developer engineer. But many of the organizations, they keep it as a separate as well. Like you will work onto the build root and you will be maintaining the builds and all those kind of stuff as well. Okay, and now the question which will come to your mind is, which career goal should I choose? Now you see, till now you were knowing like there is something like a embedded Linux. Now in embedded Linux also there are several career paths. So what should I aim for? What should I basically make my goal like, okay, I want to become this. So I would suggest, like in this current job market, you should not restrict yourself to the particular learning track. You should be basically, I can say, master of all, and your goal should be embedded Linux specialist. Now, what is this embedded Linux specialist and how do we reach here? So here is the complete roadmap to that, and that's what I call it as the ultimate roadmap to the embedded Linux developer. So the very first thing is, let's say like you don't know anything about the Linux, so you need to understand the system end to end. And how do you get there? So here is the roadmap, the journey from the novice to the specialist. And As I told, let's say you are starting now and you don't know anything about the Linux and you want to reach there to the level of the specialist. So the very first thing would be Linux fundamentals. So you should be crystal clear with the Linux environment. You should be very comfortable with the command line and all those kind of stuff. Now, once you are clear with this particular stuff, the next logical step which you need to move into is the Linux application development, which we have already discussed about. Because being in you can't simply say like I would be a driver developer and I don't understand the application. If you don't understand the application, you won't be able to understand the requirement of the user. That means you won't be able to understand the product requirement as such. So you need to understand the application development thoroughly, because application development developer request the services from the driver developer. So if you want to be a good driver developer or embedded Linux developer, it is very important that you should be clear with the application development as such. Now, once you are thorough with this particular stuff, the next logical step would be Linux driver basics. Now, what does it involve? I would say basics means like you are comfortable with something like what the Linux kernel module is. You are comfortable with the character driver. You know how to load and unload the driver. You understand about how the basic character driver related stuff and all those things are structured. Now, as you guys know, just knowing the character driver is might not be good enough to get you to the level of the Linux developer or Linux driver developer. So now what you need to do is basically you need to learn the kernel programming. We already discussed what is kernel programming. That means the programming constructs, like you have got something like semaphores, the mutexes, and all those kind of things in the kernel space, waiting or blocking the process. How do I block the user space process and interrupt management kind of things? So all of these things basically come into the kernel programming related stuff. Now, once you are done that, you can basically call yourself, yes, I can write a driver. I'm comfortable with writing a I can say driver up to certain level of sophistication, but just reading the concepts or just mugging up the things is not going to help you out. Knowing the concepts is of no use till you have practically done that. So what I would recommend is, along with this, throughout this path, you need to try out all the hands-on, the exercises. Now, where do you come to know about the exercises? Typically, see, when you will be going through the topics and all, definitely you will get some questions. Those questions can become your exercises. Okay, so you can use that particular stuff. So that's the part of the story. Now we want to go further up in this particular ladder. So now what you need to do is you need to have some projects in place. Now again, the question would be, how do I get into this project related stuff? Actually, see, many of the guys, what they do is they start contributing to the open source world, and that's what they call it as a mini project. But rather than getting that, what I would suggest is you can basically take your any embedded related project. For in the embedded system, you might have, like, let's say if you are an embedded developer and you might have come across the various projects. So how do I make that work over here? Okay, so for example, let's say there are some sensors. I want to collect some data from the sensors and I want to provide it to the user. So how do I achieve it in the driver? That will help you that will help you your project. Next, what you have got is you need to get into the advanced drivers. Now, what do I mean by advanced drivers? You should be basically aware of the device tree, binary related stuff, the platform drivers related stuff, how the overall like kernel source code is organized. So all those things are very important to get you to that level. So that's one path, but in parallel, you have the path which we call it as the embedded Linux BSP and the build systems, which we have already discussed. Again, this is a niche, and it's very important that you understand the things end to end. And this BSP development and all will definitely give you. Now, this is the thing which basically where you need to evolve gradually. It's not that in a day or two you will be getting these things. You need to have a patience and the perseverance. That is very important. So consistently you should learn on this particular stuff. Now, let's say you basically want to go fast. You basically want to, you don't have a, you don't want to spend years together in order to get this particular thing. You want to get started. You want to fast track your journey. Then I have designed one ultimate system to smooth your journey to the embedded Linux driver development. And this is what I basically call it as a Linux Rapid Mastery Program. So what does it involves? It involves the things like Linux fundamentals, Linux drivers, Linux application development, Linux kernel internals, and this will help you get started with your Linux driver journey. To get more details about this particular stuff, you may refer the description where I have provided the link to same. Like you have a weekly live mentorship calls, you have 50 plus hours of self-paced videos, 4 individual course certificates, Linux courses, in-depth uh, core topics are covered over here. So all those things are involved. You can just refer the description, you will get the detail about this particular thing. So that's it about the roadmap to the embedded Linux development. I hope you found this information useful and valuable. Do not forget to like and share this video so that it can help others. Further, if you have any queries or if you want any topic for which the videos to be posted, please put it in the comment box. I would be happy to hear from you guys. Okay, so with that note, bye bye. See you in the next video.